Let R be the region under the graph y equals 4x minus x squared above the x-axis. Find the volume of the solid obtained by revolving R about the line x equals 7. So let's make sure we have a visual of this. Here's the graph of y equals 4x minus x squared. This goes out to 4, 5, 6, 7 is here. This is now my axis of rotation. So if I've got to go 3 more before this starts, 1, 2, 3, the mirror image is over here somehow. I guess I didn't quite give myself enough room, but you get an idea of what this looks like. So to answer this question, we always need to consider what is the volume of a cylindrical shell, which I've done in my earlier videos, and I will quickly do again this time. So how does that work? We have a cylinder on the outside and we remove a cylinder on the inside. The big radius is big R, the little radius is little r, the height is h. The volume of the shell is the big cylinder minus the small cylinder, pi big R squared h minus pi little r squared h. So what is the volume of the shell going to be? Pi h, big R squared minus little r squared. What will that be? What's the volume of the shell? Pi h, big R plus little r times big R minus little r. So this is always what we want to keep in mind when we are playing with cylindrical shells. And the question is almost always going to come down to what is big R plus little r? That is the challenge that we need to look at. So let's really emphasize that. Let's think about what big R plus little r is going to be. So what is the distance? Here is my original function. Here is the y-axis. Let's make sure we're clear there. Here is the line x equals 7, which we'll look at here. I'm going to draw a little box at x and try to figure out what in the world big R and little r represent. Well, okay, little r is from the axis of rotation here, that's little r, and this is big R. But hopefully you've seen enough to recognize that big R plus little r are, big R and little r are basically the same. This is essentially going to shrink to 0. So what I need to find, what I really need to find is this distance, starting at x and getting to the axis of rotation. What is that distance? If I'm at x miles and I want to go to 7, that distance, of course, is 7 minus x. So big R is very, very close to 7 minus x. Little r is very, very close to 7 minus x. So big R plus little r is very, very close to 2 times 7 minus x. And if you want a little bit more motivation for that, the average of these two things, right? Big R plus little r over 2, that's the average of the radiuses. Radii, big R plus little r over 2, the average of those radii is going to be what? Is going to be 7 minus x. That's the distance from the axis of rotation to x. So I need this in my formula for the volume of the shell. I need big R plus little r. I also need big R minus little r. What is big R minus little r? Well, that's the thickness of this thing. Big R out to here, little r out to here. If I subtract those two things, if I subtract their absolute values, if you will, big R minus little r is simply going to be the change in x. So we have this fact that we need. Then I also need the height. The height is almost always the function. So if I draw his partner, as I rotate this, it's over here somewhere. What's the height? The height at that value x is the value of the function. Let's draw in a cylindrical shell, now that we've defined all those other important pieces. So the height of that cylindrical shell is just the value of the function. Almost always that's the case. So the height h is the value of the function, which is what? Which is 4x minus x squared. So this now is enough for me to find the volume of this shell. Then I will find the volume of n shells. Then I will find the volume of an infinite number of shells. Okay, so this was our previous page. This is what we had said. Is the volume of a shell is pi times h times r plus r times r minus r for a given shell. So this is the shell we're interested in for this value of x. What am I going to get for that value of x? What's the volume of the shell? Is pi. Height is the function, which is what? Which is 4x minus x squared. The hard part is figuring out r plus r. One more time. R, the radius, is the distance from the axis of rotation to x. From x to 7 is 7 minus x. So one of the r's is basically 7 minus x. The other, the little r, is basically 7 minus x. So r plus r is basically 2 times 7 minus x. So we have pi, we have h. R plus r, we're saying, is 2 times 7 minus x. Whoops. 2 times 7 minus x, and r minus r, big R minus r, is going to be change in x. That is one shell. Then I want the volume of n shells. That's the sum over all n of them. So how do you visualize that? We visualize making a bunch of these rectangles, right? Here's one, and here's one, and here's one. We get the idea. And we're going to have n of them layered all on top of each other. So all n shells would be pi times 4x minus x squared times 2 times 7 minus x delta x. So we want to send n to infinity. So the number of shells goes to infinity, which means delta x goes to 0. And that is going to go from a sum to an integral. That, of course, is thanks to the Riemann sum concept. So the volume of the solid is the integral. What does x range from? Looking at our previous picture, x ranged from 0 to 4. X ranged from 0 to 4 of pi times 4x minus x squared times 2. And then as delta x shrinks to 0, this becomes the differential dx. And this is certainly an integral that most students at this level are capable of doing. I am going to jump to Wolfram alpha to help me do that. So what do I need? Pi, 4x minus x squared times 2. Replace this 2 plus x with 7 minus x. And that should give me an answer. Let's see what we get. What does it give me? What does it give me? 320 pi over 3.